So, referring to this example, again, we need to write a cell diagram. So each galvanic cell has a cell diagram. The cell diagram is denoted like this. We take the anode at the beginning and the cathode at the end, and between them we have the salt bridge. So we can start. Here we use always the zinc in the solid state. We write a physical boundary here, and then we have the zinc ion, Zn2 plus, aqueous. Here we have, this shape is the salt bridge, and then we write the ions, Cu2 plus, aqueous, and finally Cu solid. So it starts with a solid and it ends with a solid. The zinc, the anode, solid, and Cu is the cathode, solid, and between them we have the salt bridge. So this is the salt bridge, the salt bridge sign. Let's take another example to make sure that we understood this. Given the overall reaction and the cell diagram, if you have the cell diagram, you can use this cell diagram to find the half reactions from it. If we have this cell diagram, Al solid, Al3 plus aqueous, salt bridge, Cd2 plus aqueous, Cd solid. We can know that oxidation is at the anode. So what's the oxidation half reaction? Aluminum is oxidized, so we can write here Al and here Al3 plus. And how many electrons are needed to balance the Al3 plus? We add 3 electrons. The reduction half reaction is at the cathode. And who is at the cathode? Cd at the cathode. So it will be always start with the ions and end with the solid. So Cd2 plus 2 electrons to balance it, since it is 2 plus, to give Cd solid. So from the cell diagram or the cell notation, I can write the oxidation and the reduction half reactions. If I want to write the overall reaction now, if they told us to find the overall reaction, keep in mind, whenever we need to find the overall reaction, we need to balance the electrons. So we have in the first reaction 3 electrons, and in the second half reaction we have 2 electrons. So to make it the same, we multiply the first reaction by 2 and the second reaction by 3. Now we can get 2Al solid And the other reaction, the second reaction is three CD solid. So the overall now 6 electrons and 6 electrons are removed, so we can get 2Al solid plus 3CD 2 plus aqueous gives 2Al3 plus aqueous plus 3CD solid. So from the cell diagram we knew how to write the oxidation half reaction, the reduction half reaction, and the overall reaction. Let's take now another example. If we have this reaction, overall reaction, the question is, write a cell diagram for this from this overall reaction. If we notice that PB is doing reduction, so PB is changing from positive 2 to 0. So this is reduced. So here we have reduction. And iron is oxidized. We have iron aqueous, PB aqueous, iron aqueous, PB solid. In the cell diagram we said it should start by a solid. It should start by a solid at the anode and ends with a solid at the cathode. In this example, we have iron as an aqueous. We don't have, at the anode, we don't have a solid. So, in order to allow this galvanic cell to work functionally, to function normally, we assume that a platinum electrode is used. So when we don't have a solid, we use a platinum electrode to make a surface for the galvanic cell to take place. So in this case, if we want to write the cell diagram, we can write it like this. First of all, we have Fe2 plus, which is the anode, aqueous. Fe3 plus, aqueous. A salt bridge, Pb2 plus, aqueous. Pb solid. And we add here the platinum. So we add here at the beginning the platinum solid. So this is the anode side and this is the cathode side.